Hello students, today we are going to discuss about geometry. Coming to this topic has been widely asked in many examinations like your BBA examinations or even any quantitative aptitude exam will have this geometry part. But what type of questions will be asked will differ from exam to exam. Like for example, coming to CLAT examination or any other normal examination, geometry is just confined to mensuration itself. That is 2D geometry. But when you are when you are attempting IPMAT or any BBNS examination, it will go some part of coordinate geometry also. That means you have to know about every property related to shapes and their application with coordinate geometry along with trigonometry. So you have to know everything. So we cannot constrain ourselves to geometrical shapes only. You have to know about area of triangle, along with that properties of triangle. Okay, this area of triangle is just only confined to some part of the examinations, like different shapes will be given. In that you have to divide that shape into different number of triangles and you can find the area of the whole diagram. Or sometimes they will ask surface area like that when it is going into 3D shape. But coming to this part of geometry, it's very different, as I said previously. Now let's see what all the questions that can be asked in this geometrical part. Yeah, see, for example, in this question, two poles of height 6 meters and 11 meters stand vertically upright on a plain ground. If the distance between their foot is 12 meters, find the distance between their tops. So here, although this question is very easy, as you see, it's very easy. Like one pole is of 11 meters, another pole is 6 meters, and the distance between them is 12 meters, and the distance between the tops of the poles will be the difference between these heights. The vertical distance is 5 meters and this is 12. So applying Pythagoras theorem will get this as 30, or you can simply say that it is a application of triplets, right angle triplets. But observe this carefully. So when you apply geometry or when you want to solve geometrical questions, try to imagine the diagram before applying it. Sometimes the question will be asked like this: find the shortest distance between a point and a circle. I hope I gave this question, but okay, fine. A point and a circle. What is the maximum distance that a point and a circle can have? Some say it is the distance between this point and this point, or this point or this point, or sometimes from this point to the center of the circle. That means you have to find maximum distance. But who said only this distance is possible? That's the problem of our imagination. Why not the distance of that point is maximum inside the circle? Why not it's not a chord of a circle? Why not it's not present on the chord of a circle? Why not it's a center of a circle? Okay, so you have to check that. You have to check for every other possibility. For this question, there is not that much is involved in this question. That much thinking is not involved in this question. But you, for every geometry question, we have to think more before applying that. Okay, let's go into the next question so that we can find that type of things. Okay, see this. Find the area of shaded region if the radius of each of the circle is 1 centimeter. And not only IPMAT Indore but Rohtak also, they are very much inclined towards asking these type of questions like shaded area. Okay, yeah, these questions are very much expected. So what is the area of one circle with radius 1 centimeter? It is nothing but pi r square. That means pi only. So this area is pi and this area is pi. Okay, now we have to find this part of area and remove this area. How we know this part of area is nothing but area of triangle. Okay, so area of triangle is nothing but half into base into height. So what is base here? Base is this addition of two radius So base is 2. What is height? Height is nothing but, we can apply our Pythagoras theorem again. Here again this is 1 and 1. The hypotenuse is 2. Base is 1. So 1 square plus the height, h square, is equal to 2 square, that is 4. So h square is nothing but 3. Height is root 3. So if height is root 3, we'll take it as this. So the area of this triangle is root 3 units. Okay. Now from this we have to find the area of shaded region. This region. So to remove that, to take that area, first we have to remove this sectors area. What is this sector area? How we will know this sector area? As you already know, this is an equilateral triangle. By dimensions we came to know that, because this side length is 2 and this side length is 2, this side length is 2. So that means this is an equilateral triangle. And what is the angle between any two sides in an equilateral triangle? It's 60 degrees. Then what is the length of this arc? How much it is? Theta by 360 into area. So what is theta here? It's 60. So it's 1 by 6. So pi r square by 6, or radius is 1. So each area will be pi by 6. How many areas are there in that? There are 3. That means the area is pi by 2. So the whole area of this triangle minus this area of the blue area will give us the shaded region. So here the shaded region means the middle part. Actually I changed the colors, that's why it is in this way. So pi by 2 will be less, because the area of the triangle is more. So root 3, I think that's the answer. I think root 3 minus pi by 2 will be the area of the shaded region. So remember what we have done? We have taken the area of each circle, and along with that we found area of this triangle, because area of triangle here is equilateral triangle, area of equilateral triangle. So we got it through half base into height. From that we removed the 3 portions of the circle which are covering in that. So we got that area of that sector, that part of sector from triangle, through finding the area of sector, how much angle it has been made. Okay, so it is theta by 360 into pi r square. Then that way we got it as pi by 6, because r is 1. So for this pi by 6 there are 3 parts. So 3 into pi by 6 is pi by 2. So root 3 minus pi by 2 became the area of this shaded region. Okay, so in this way we will find different problems. So here imagination again, imagination. So when you think this area, you should not say that it's 1/3 of a circle. Remember, it cannot be 1/3 of a circle. There will be the problem occur from here. Okay, I think in Indore, yes, in Indore only a problem is given this year, that in a triangular park is there, a dog is running around this triangle, and it is turning around the curves with a radius of 1 only, I think. So what is the length of that whole area, length of that circumference of that new triangle? So this area, sorry, not area, this circumference, this perimeter of this triangle. So this was the question. So here also the same application will be there, but it changes here. Up till here it will be same as this triangle only, the original triangle, but here it converts as a circle, not a semicircle, but 1/3 of a circle. So how many circles are 1/3 are there? 1, 2 and 3. So it makes a complete circle. So what is the circumference of that new path? It is nothing but this perimeter plus circumference of this circle. Okay, so imagination is the important thing, is the key in geometry. So don't forget that. Let's go to the next question. Yeah. In the following figure, find the value of x. So here I think angle B is 110. So angle B is 110 degrees. So here we have to apply the properties of circles here. So in the properties of circle, directly we can apply this, we can find this value of x through properties of circles. What properties of circle will say? Any chord, okay, a chord subtends a same angle anywhere in its arc. whether it is a major arc or a minor arc, it subtends same angle. If it is subtending 30 degrees here, at any point on the circle, on the major arc, it will subtend 30 degrees only. It will be same. That means this angle is also 30 degrees. So in this triangle, the value of x would become 30 plus 110. It will be 140. It should be removed from 180. So the value of x is 40 degrees. So it is properties of circles, properties of major arc, minor arc. They are very important. We have to apply it every time when you see this type of problems. And you also have to see the theorem of chords, intersection of chords. If this is a circle, there are two chords intersecting like that. These are chords, not diameters. These are two chords intersecting. Then what will be the property? This is AB and this is PQ and this is D. I mean, this is not the center. This is the intersection point of two chords. Then what will be the property that you have to apply here? See that. That's very important. In properties of circles, is very important theorem. Okay. Going to the next question. Similar triangles. Yeah. This coming to properties of triangles, we have to know side similarity. I mean, similar triangles and congruent triangles. So what types of similarities are there? What types of congruencies are there? We have to know it. So before going into that, I briefly discuss these things. One is side similarity. Okay, I mean two triangles can be set in similar when they have all sides have similar sides, or angles have similar sides, or side angle side symmetry. Okay, that means if two triangles are there, if it has corresponding sides, if this side S1 is equal to this S1, not equal to having same ratio, and this angle is similar to this angle, and this side too is similar to this side too, obviously remaining angles and remaining sides will have to be similar. Similar means having the same ratio. Congruency means same, equal, having the same size. So here what they said, the area of similar triangles ABC, the area of similar triangles ABC and DEF are 144 centimeter square and 81 centimeter square. If the longest side of the larger ABC, larger triangle ABC be 36 centimeters, then the longest side of the smaller triangle DEF is. So here similarity theorem has been applied, and they already said that they are similar. So no need to check whether it is side similarity or angle similarity. Okay, so here we are applying similar triangles, and their areas are in the ratio of 144 is to 81. If you take the ratio, it's 12 square and 9 square. So if I cancel that, what I'd get? So I have a 9 here, so 16 divided by 9. Okay, so it is 16 is to 9. So the larger triangle ABC, and this one would be in the ratio of 36 by x is equal to 16 by 9. So it is 4 4s and 4 9s, and obviously wait a minute. Okay, sorry, their ratios are in the ratio of squares, so let's not go into that. So it's 4 by 3. So this ratio has to be 36 by x has to be equal to 4 by 3. So this is 9, and obviously x is equal to 9 by 3, 27. So the areas are in the ratio of squares of their. So we have to take square root on that, and we got it as 4 is to 3. So their sides are in the ratio of 4 is to 3. That's why they are similar. If not, they would be congruent. Okay. So that is about similar triangles and congruent triangles. You have to know about different properties of triangles also. What else are there in the properties of triangles? It's like the exterior angle is nothing but sum of opposite two internal angles. Okay, so you have to know this one. You can apply this rule also everywhere in a triangle. Okay, so these properties are very much required for for solving this type of problems. Let's see the next question. Okay, a chord is drawn inside a circle such that the length of the chord is equal to the radius of the circle. Now two circles are drawn, one on each side of the chord, each touching the chord at its midpoint and the original circle. Okay, let K be the ratio of the areas of bigger inscribed circle and the smaller inscribed circle, then K equals to. So they are asking about the ratio. Yes. So I want to discuss this concept. What is that? whenever a circle is there, and if you draw a chord, it will obviously intersect at two points. When you have to draw a triangle with other two sides be radius, okay, with other sides be radii of that circle, then obviously this triangle would become an isosceles triangle. Okay, that means two sides will be equal. And if at all, if you draw a perpendicular from that center to that chord, it will divide it into two right angle triangles for sure in any circle. Yeah, this property can be applied to any circle. In a circle, if you draw a chord, it will make an isosceles triangle with the center. And if you divide that isosceles triangle, it would make two right angle triangles. That is the property that we already know with isosceles triangle. But what new here what we are learning here, it is whenever you draw a chord, it will form an isosceles triangle in a circle. So now with that property we'll apply this one. So what they are saying, a chord is drawn inside a circle, yes, such that the length of the chord is equal to the radius of the circle. That means even this is equal to this and this. That means it's an equilateral triangle. Yes, but now two circles are drawn, one on each side of the chord. So observe this carefully. Whenever they say two circles are drawn, one on each side of the chord, you can, you have to think it as like this. Okay. Now two circles are drawn, one on each side of the chord, each touching the chord at its midpoint. This is the critical thing. If not, if they don't give that, we cannot assume that whether the circle, the inside circles can be like this or like this. They can be very small because both are touching the chord and even the circle also, but they are touching the midpoint. The midpoint touching circles would be only this one. Okay, now the ratio of their areas of the bigger inscribed circle and the small inscribed circle has to be known. So let us solve this one. So if this is a circle and r be the radius of that circle, and now what is this length of the chord? This is also r. And what about this height then? This is the center of sorry, if my diagram is wrong, let me draw it again. Let me be good in that. Okay, this is the center of the circle. This is the chord and these are the radii which makes isosceles triangle. Now this will be the center of the larger circle. I'm not changing the color of the circles. I'm sure that you understand this one. So here the radius of this bigger circle will be r, and this would be √3r/2. So this is the height of this isosceles triangle, right? So that means what is this diameter? It's nothing but this whole thing is radius r, that we know, the bigger circle's radius. So the small circle's diameter is nothing but the whole radius minus this height of this isosceles triangle. Remember, just we are removing only this part to get this diameter. So what is that? R minus √3r/2 will be the diameter of this small circle, isn't it? Now I can take r common, so I'll get 1 minus √3/2, and it is again half for the radius of smaller circle. Radius of smaller circle is nothing but half of the diameter. So we got diameter here. Okay, now diameter of this bigger circle, what is that? It's nothing but the length of this chord, this diameter, this line segment is from this center to this end point is nothing but r, radius of the bigger circle, radius of the original circle, plus this √3r/2. So r plus √3r/2, which is not r1 plus √3/2, would be diameter of this inside bigger circle. For radius, I will half that. Okay, now I got radius of two circles. With this, can I find the areas? Yes, pi r1 square by pi r2 square. So they asked the ratio of the areas of bigger to smaller. So this bigger circle and smaller circle, so pi and pi gets cancelled. The radius will be r square by 4 1 plus root 3 by 2 whole square divided by again r square by 4 1 minus root 3 by 2 whole square. So this thing and this thing gets cancelled away, and I will be left with 1 plus root 3 whole square by 1 minus root 3 whole square. I mean, yeah, 2 minus root 3 and 2 plus root 3, because we have to take LCM here. Okay, so this is the thing, and if you want to apply and if you have to rationalize this, I think the answer would come at 97 plus 56 root 3. So you have to rationalize that 2 plus root 3 whole square, it will go up till 4 plus 377 plus 4 root 3, and here it is 4 minus root 3, it will be there, 4 minus 2 root 3, like that. Yes, and you have to rationalize that. If you want, I'll do it. So 4 plus whole square, a plus b whole square, it will be 7 plus 4 root 3, and here it is 2 plus 3, it will be 7 minus 4 root 3, and if I rationalize that, I would get 7 plus 4 root 3 and 7 plus 4 root 3, it will be 49 plus 4 into 3, 16 into 3, it will be 48 plus 4 28 56 root 3 divided by 49 4 16 is 48, 49 minus 48. Yes, obviously it will be 97 plus 56 root 3. Yes, so what we have done, I'm just summarizing that again. So here we have drawn a chord which has a radius, which is equal, whose length is equal to its radius, and we draw an inverse circles. One is bigger and other is smaller. We have to find the areas of the circles. For that we need to find the radius. So for that radius, I have a clue called a midpoint is a clue for me. So for that, what I have done, I took this as the height of the triangle, and I got height through applying Pythagoras theorem. When I remove that from this whole radius, I got the diameter of smaller circle and I got the radius of smaller circle. And again, same way, if I add that to the remaining radius, remaining part of the radius, I'll get diameter of bigger circle. So here I have to half them because it's the diameter of them. So I got radius of each circle and I found the area as this one. So this is a thing for when we are applying geometry in circles. Okay, so here we have to learn that whenever a chord is drawn, it will form an isosceles triangle, and we can apply the different properties of circles again in that. Okay, coming to this, the other polygon, point P, Q, R and S are taken on sides of A, B, BC, CD and DA of square ABCD respectively, so that AP is to PB is to PQ is to QC. I think this is a previous year question. Yeah, is equal to CR, and RD equal to CR is to RD is equal to DS is equal to SC. That means every line segments are in the ratio of 1 is to n. Then the ratio of the area of PQRS to the area of ABC. So let me draw this diagram. Point figure segment size of a square. Okay, a square is drawn, ABCD. On that, PQRS is another polygon. It's a quadrilateral. PQRS. Let me draw this nicely. Okay, which divides each side in the ratio of 1 is to n, 1 is to n, 1 is to n, 1 is to n. Now, then the ratio of the area of PQRS, this means the inner square and the area of the bigger square. We have to find the area. So, and I don't know the side, the length of the square is not given, right? So how to do? Let us say the length of the square as L. If L is that, then what is the length of this line segment which is got bisected by Q, which has bisected in the ratio of 1 is to n. It's not bisected, it's been intersected. So it will be 1 by n. L by n is this, and other would be this line would be, sorry, L by 1 plus N, because they are in the ratio of 1:n. They are not in n parts. So N into L by 1 plus N will be the other segment. So we got these line segments. Now imagine again, if you remove 4 corners from a square, okay, if you remove 4 corners from a square in the same ratio, everywhere in the same ratio, again that will form a triangle, right? A right angle triangle. So what would be the area of that right angle triangle? It will be half into base into height. So every right angle triangle will be same because they are in the ratio of 1:n only. Everywhere I am cutting with 1:n. That means if I cut with, here 1 and this would be n, obviously this has to be 1, okay, because 1:n has to be maintained. So like that I'll get 4 right angle triangles whose area would be same everywhere. That means if AP's length would be L of by 1 plus n, this height would be n of 1 plus n of L. Okay, now this is base and this is height, half into base into height. So how much it would be? N by 2 L square by 1 plus n whole square. So that would be the area of one right angle triangle that has been cut from the corner of the bigger square. So we have to find it for 4 corners like that. So 4 into n by 2 L square by 1 plus n whole square. So 2 into 2, that would be 2n L square by 1 plus n whole square. That would be the total area of these 4 corners taken together. Now, what would be the length, the ratio of the area of PQRS if I have to know the area of PQRS, which is nothing but, so remember this 2n L square by 1 plus n square. What is that? 2n L square by 1 plus n whole square. So this was the area of the removal. Now, we have to remove this from the bigger area. So L square minus 2n L square by 1 plus n whole square is the area of PQRS. Now what is the area of ABCD? Yes, L square. So L square, ratio of the area of PQRS to the area of ABCD. So bigger one should be in the down. So L square of 1 plus n whole square minus 2n L square divided by 1 plus n whole square, and this thing has to be divided by L square, which is the area of ABCD. So this L square and this L square gets cancelled. So let's expand this. It would be 1 plus 1 square plus n square, 1 plus n square plus plus 2n, and L square has to be taken common. Okay, don't forget this. L square is taken common away. So minus 2n divided by 1 plus n whole square. So which is nothing but this 2n, this 2n gets cancelled. 1 plus n square by 1 plus n whole square. Okay, option C. So here what we have done, here the each side is divided in the ratio of 1:2. So again you can apply this, you can generalize this. What if this ratio is 1:1? That means if each point is the midpoint of each side of a square, you can apply that as 1. So what is that? 1 plus 1 and 1 plus 1. It is 2 by 4, means half. So area of a square whose midpoints are again made into a square, are again drawn into a polygon, whose area would be half of the original area. So in this way you can get the rules and you can get the answers. Okay, fine. Come to this one. On a circular path of radius 6 meters, a boy starts from point A on the circumference, okay, and walks along a chord AB of length 3 meters. He then walks along another chord BC of length 2 meters to reach point C. Then point B lies on the minor arc AC. The distance between point C from point A is. So here, again I am saying, imagination is the key point. See, on a circular path, a radius of 6 meters. Okay, a boy starts walking a point from point A on the circumference and walks along a chord AB. Okay, of length 3 meters. So this length is 3 meters, not centimeters, it's meters. Okay. He then walks along another chord BC, okay, of length 2 meters to reach point C. The point B lies on the minor arc AC. Okay, so minor arc is this. This is called as minor arc of AC. Okay, the distance between point C from point A is. So they want to know this distance. Don't get confused with it as diameter or it has a Pythagoras theorem when it has a right angle theorem. Okay, why not right angle? Because nowhere it is mentioned that it is going to have, I mean, perpendicular. He is not going in a perpendicular way from this point to this point. So one thing is not given like that. Another thing also, if it is perpendicular, if at all this is perpendicular, it has to be, I mean, if you apply Pythagoras theorem, 4 plus 9, it would be root 13. Root 13 would be very less than this thing, I mean the diameter. So again, you may think that as a thing, you may think that as a 90 degrees, but every time remember an arc, I mean two line segments, I mean a chord makes 90 degrees only if it is a diameter. Okay, that is a rule again. A diameter only makes 90 degrees on a circle. So if that is not 90 degrees, if that is not 90 degrees, this cannot be a diameter. Okay, so in this way also we can say this cannot be a right angle triangle. So yes, that assumption is not possible. Then how to do this one? So if you draw this diagram correctly, chord wavelength 3 meters. Okay, so this is the center of the circle, center of this circle. So radius would be same for every point, right? Here it is 6, here it is 6, here also it is 6. Now I want this length. Okay, whose length is 3 and this is 2. So I got every length. So remember, whenever this point occurs in your calculation where you have lengths of every side, but you don't have any clue to solve, like I don't have any clue to solve here because there is no 90 degrees here and I don't know how much angle is subtending here and here to make it as a right angle triangle or else. Okay, so even this is not exactly perpendicular to this AC, so I don't have any information like that. Then I'll go to trigonometrical application. Okay, so that's the only way you can do this one. So if I think this as an angle alpha and beta, can I know cos alpha? Can I know cos alpha? Yes. How it is? Applying cos rule. What is that? A square plus b square minus c square by 2ab. Okay, so in that way, so if you think this as alpha, what would be this a square plus b square? It's nothing but these two things, 6 square plus 6 square minus c square by 2ab, 6 into 6. So that would be cos alpha. So solving this, cos alpha would be 72 minus 9 divided by 6, that is 272. So it is 63 minus by 72, which is nothing but 7 9s, sorry, how much it is? Yes, 7 by 8. Okay, so cos alpha is 7 by 8. So whenever you write it into trigonometrical ratios, try to find its sine also. So how much is sine? It's nothing but 1 minus cos square alpha. So that is 49 by 56. 56 minus 49, I'll get it as, sorry, 64 minus 49 divided by 64, that is 15. Yes, root 15 by 8 again. So sine alpha is root 15 by 8 and cos alpha is 7 by 8. So remember that. Again, with this triangle, in this triangle, I have to know beta. So with that, what I'll get? Cos beta is equal to, again, 6 square plus 6 square minus 4 square, that would be 72 minus 4, it would be 68 divided by, again, 2 into 6 into 6, that would be 72. So how much it is going? 1 4, it is 4 1s 4 7s by 18. Cos beta is 17 by 18. Check it once. Yes, yes. And sin beta would be 1 minus 17, 289 minus 364, 324. How much? Root 35. Root 35 divided by 18. Okay. Sin beta would be root 35 by 18, and the sin alpha is root 15 by 8. Yes, 35 by 18. Okay, fine. We got it as 68 by 72, and other is, 17 by 18, and other as root 35 by 18. So cos beta, sin alpha, cos alpha. So what you are getting from this, it's nothing but you can apply cos rule to this triangle. Let me change the color of the pen so you will get it. We can apply that cos alpha plus beta to this triangle now. So cos alpha plus beta is nothing but 6 square plus 6 square, that is 72, minus, let us call this as x square divided by 2 into 6, 72. So cos alpha plus beta is nothing but cos alpha into cos beta minus sin alpha sin beta is equal to 72 minus x square by 72. So cos alpha cos beta, this into this, so it is 7 by 8 into 17 by 18 minus sin alpha, this one, root 15 by 8 into root 35 by 18, that would be this one, 72 minus x square by 72. So with this we'll find exactly the value of x square, that is the value of this thing. Okay, so if you find root to that value, we'll get this as our answer. So remember, we are applying here the cos rule. So the cos rule here will apply only when we have every lengths of, dimensions of every length of the triangle, but we don't know, we don't have any other clue. I cannot apply a right angle triangle here, Pythagoras theorem or any other isosceles triangle theorem also here, because I cannot apply this here, because this line segment is not given as perpendicular, or it is not bisecting that chord AC. Okay, so in this time, or in this way of asking questions, we can apply cos rule. And similarly, sin rule also, you have to see for sin rule also, what is sin rule and how this sin rule will be applied. Recently in indoor question, there is an application of sin rule, and where you have to find the value of x circle, radius of circumcircle, I think. Yeah, sin alpha by A is equal to sin alpha by sin beta by B is equal to sin gamma by C should be equal to 2r. 2r is the radius of circumcircle. So these type of applications would be there. Okay, so we are. So get ready with those questions. Okay, next, locus question. So yeah, locus type of questions were not generally asked in any other BBA examination. This is the one sort of question that has been asked in Indo. So let's see that. 2 points on the ground are 1 meter apart. If a curve moves in the field in such a way that its distance from the 2 points is always in the ratio of 3:2. So what is meant by this locus problem? The locus is nothing but it will prove the same rule in every way it moves. So that means the 2 points on a ground, let us say, are 1 meter apart. Let us take this as origin whenever we have to go into coordinate system. Yes, we are going into coordinate system now. Okay. 1 meter, so 1, 0, this becomes 1, 0. We are in x-axis. 2 points on a ground are 1 meter apart. If a curve moves in the field in such a way that its distance from 2 points is always in the ratio of 3:2. That means if a curve is tied here, x comma y, its distance from this point and this point would be always in the ratio of 3:2. So x square plus y square root divided by x minus 1 whole square plus y square is equal to 3/2. So squaring on both sides, we get x square plus y square is equal to 9/4 So 4 if it goes here and it comes here, x minus 1 whole square plus y square. Okay, so yes, this thing would go as soon as possible. That's as 9x square plus 9y square minus 2x, that means minus 18x, and other thing would be plus 1, that's why plus 9. Here it will be minus 4x square minus 4y square, so it would be 5x square plus 5y square minus 18x plus 9 would be equal to 0. So it is in a generic form of circle. You have to know about the generic forms of circle, ellipse, and what is that, hyperbola and everything, so that parabola, so that you can easily solve this type of locus questions. Yes, in coordinate geometry we are going to move into coordinate geometry now. So whenever this type of question asks, you should have an idea of what is the general equation of a circle. Okay, general equations of every shape. Yes, so with this I think we have completed geometrical part, and we should know this type of basics every time when we enter into when we solve geometrical questions. Now let's start coordinate geometry. So in coordinate geometry, it is not it's nothing but, as you have seen in the previous problem, it is nothing but an extension into coordinate system. That's it. You should have you can apply every property that you have learned in circles, triangles and quadrilaterals. So you can apply those properties again with coordinate geometry. That's the only difference we have to find here. Just let's go in this. The area of triangle is 5 square units. Two of its vertices are 2, 1 and 3, minus 2. The third vertex lies on y is equal to x plus 3. What will be the third vertex? So generally coordinate geometry questions can be solved through applying through options, but sometimes it's not a good idea. So I prefer not to go in that way. If it is a smart way, whether it is smart way or not, it depends on the question. Okay, so the area of a triangle is 5 square units. So what with the area if you have given some points? Yes, it would be half of base into height. So yeah, one thing is the third vertex lies on vertex y is equal to x plus 3. What will be the third vertex? So one thing is you can prove in this way also, minus 7 and this one. This is not applicable. 4 equal to this one. Yes, this is applicable. And minus 7 minus 4 is not applicable. Minus 4 plus 3, no. So yes, through options you can say this is the answer, but I don't prefer in that way. So here the area of a triangle is 5 square units, that is given. Two of its vertices are 2, 1, 3, minus 2. So the third vertex is not given, y is equal to x plus 3. So without any shortcuts, let's go and apply our formula, which is half of x1 of y2 minus y3 plus x2 of y3 minus y1 plus x3 of y1 minus y2. That is the formula for finding area of a triangle with 3 vertices. So if I apply that, this is the modulus. So we have to apply every vertex. The third vertex will be, let it be x1 or no, so not x1, it would be x comma x plus 3. So this has to be substituted here, and that has to be equal to 5 square units. And I prefer not to go through any options, because options here are wrong. The given answers were wrong here. So if I apply that directly, x1 will be 2 of, let it be x1 y1 x2 y2, x1 of minus 2 minus of x minus 3, because I have taken this as directly as y3. So plus x2, that is 3 of y3, that is x plus 3, minus y1, that is 1, plus x3, that is x of y1 minus y2, 1 plus 2. So this has to be equated to 5, or half of modulus will become here as 10. So if I solve this, I'll get an equation in x. Let us see that. Minus 5 minus x, it will be minus 10 minus 2x. plus 3x x plus 2, that would be plus 3x plus 6, x plus 3, that would be 3x, that would be plus or minus 10, because I have taken the modulus out. So minus 2x plus 3x and plus 3x, it is 6x, minus 2x, it would be 4x, and minus 10 minus 6, it would be minus 4, that will be plus or minus 10. Check clearly whether it is right or wrong, because if this is x and x plus 3, x1, x2, y3. Okay. Okay, fine. 2 of minus 2 minus x minus 3, because that is y3, x2. So clearly see these things. Whenever you take modulus out, you will get plus or minus 10. So you'll get two equations and we'll have two values. Two possibilities would be there. So when the two possibilities are there, there will be no one vertex. It can have two vertices. A triangle cannot have two vertices. You have to choose only one among them, because a vertex can be of like these two are 2 points on a coordinate axis, and other point can be here and here, which has same area again. It can have same area like this. So that's why they will get two vertices. So remember that and take any one option. Okay. Generally, if they are given two options, obviously that would be wrong. Here the questions are not right. So let us check it whether they're right or wrong. Okay. Check yourself. Going to the next question, what will be the length of the perpendicular drawn from the point 4, 5 upon the straight line 3x plus 4y? It is very easy question and direct application. So it is just like solving directly. What is that? Whenever a line is given like ax plus by plus c equal to 0, whenever a point x comma y has to be, we have to find the distance between these two, then it would be ax1 plus by1, if this is x1 comma y1, plus c modulus, that has to be divided by root over a square plus b square. This a and b are nothing but coefficients of those lines, so you can clearly find it out. Apply these two things. 12 plus 20 minus 10, so it will be 12 plus 20 minus 10 modulus divided by 3 square plus 4 square, it is 9 plus 16, it would be root 25. So it is 12 plus 20, 32 minus 10, it would be 22 by 5. Okay, so modulus, if you take modulus, it would be plus or minus 5, but you can take it as 22 by 5. So the magnitude is 22 by 5. It's just the application of your general geometry to coordinate axis. Okay, find the area of the triangle whose vertices are 1, 3, minus 7, 6 and 5, minus 1, and I hope you already know the formula and you can comment that area in the comment section. Okay, let's go to the next one. The area enclosed by the curve 2 mod x plus 3 mod y equal to 6 is. So again here, in this coordinate axis, 2 mod x 3 mod y can be taken as 2x plus 3y equal to 6, or 1 negative or 1 positive 2x minus 3y equal to 6, and other would be minus 2x plus 3y equal to 6, and other would be minus 2x minus 3y equal to 6. So these are the 4 lines that you have to find area among and closer by those 4 lines. So if you take intercepts, make x equal to 0, y would be 2, y would be 2, and for x-intercept, make y as 0, it would be 3, so 3 comma 0. So same coordinates will be there again, it would be minus 3 comma 0 and 0 comma minus 2. Okay, so you have to find the area enclosed by these 4 lines. And if you don't want to extend this, you can just find the area of this right angle triangle, this shaded area, and multiply with 4. Both are equal. Half into base into height. So it would be 3 and 3/4 12. 12 square units is the answer. Or if you can find vertices, and you can find in that way also. Okay, you can find this line. So 3 square plus 2 square, it would be 9 plus 4 root 13. And again, if it is a square, you can find the area also like that also. not root 13, it would be 2 minus 0 whole square, 9 plus 4, 13. No, it's not, it cannot be a square. I think it is a rhombus. Okay, so it cannot be in that way. So you can find this way only. It is not a square. Yeah, it cannot be a square. It is not 90 degrees. Who said it is 90 degrees? Who said it is perpendicular? So we cannot apply the square area here. Okay, let's go to the next question. The next model is number of points having both coordinates as integers that lie in the interior of the triangle with vertices 0, 0, okay, 0, 31, 30, 0. So this model has been asked once in your indoor examination, and this type of question has been anticipated every time in CAT. So let's see how to solve this type of question. Let's understand this. Number of points having both coordinates as integers. This is an important model. Maybe if you have, if Kozhikode exam has to be tough, these type of models can be asked. So understand this. That lie in the interior of the triangle with vertices 0, 0, 0, 31, and this as 31, 0. Okay, so how many integer coordinate points has to be there? So there are many points actually, but integer points would be only finite. If they don't ask integer points, coordinates is integers, if this point is missing, there will be infinite points. Okay, so as they are integers, we have to find how many points are there. Again, other key point is interior of the triangle. Okay, they are not asking what are the points on the triangle. Also, we cannot include these points. Okay, we cannot include 0, 31, 31, 0 and 0, 0. The vertex is also not included. How many points, integer points are there in this? Okay, so to find that integers, first of all, let's see what all points are possible if this is a line. How many points are there, integer points, integer coordinate points are there on this line if my a line is 0, 1. It is passing through, sorry, 1, 0, x equal to 1. So if x is equal to 1, the axis, this axis would be, you can find the what is this line equation. You can find the line equation. I can say what is this coordinate point, what is the exact coordinate point here. So let us say 0, 31, 31, 0. So what is the exact equation? X minus x1 is equal to y2 minus y1 by x2 minus x1 into y minus y1. Okay, that would be the equation of 2-point form. So let us take x minus 0. I'm working with this one. So x minus 0, y2 minus y1. So 0 minus y1 is 31 divided by x2. So this is x2. 31 minus 0 divided into y minus 31. Okay, so my equation would be x is equal to minus y of minus 31. So it would be x plus y equal to 31. So my line equation here is x plus y equal to 31. That means if x is equal to 1, if x is equal to 1, line is passing through this, y would be 30. So exactly this point is 30, 1. Sorry, 1, 30. Okay, that point is on the straight line, but I don't want that point. So integer points should be interior to this triangle. That means if I go 1 point less, the next integer point would be 29. 1, 29 here. 1, 29 here, and like that, how many points are there with me here? Starting from, I cannot take this 1, 0 also. I have to work with excuse me, 1, 1 to 1, 29. So how many points are there like that? There are 29 points are there in that way. Similarly, I have to count for this one and this point 2, 0, 3, 0 and so on. So let's see for 2, 0. If x is equal to 2, y would be 29. That means the next integer point to 29 would be 28. So starting from 2, 0, sorry, 2, 1 2 comma 28, how many points would be there? There would be 28. That means, and so on up till where I have to find? I have to find the next, the before integer, the pre-integer point to 31 comma 0, that is 30 comma 0. So if x equal to 30, y would be 1. If y is equal to 1, it would be this point. There will be only 1 point. So how many integer points are there like that? From 29, 28, 27 and so on up till 1. So you can find how many points are there by using sum of natural numbers, that is n into n plus 1 by 2. So 29 integers are there, so 29 into 29 plus 1, 30 by 2. So it is 29 into 15. 30 into 15 is 450. 29 into 15, it would be 450 minus 15, 435 is the answer for this question. But what if they ask along with these points, then we will get these as 29 plus these 2 points, that as 31 points here, and here I'll get 31 to and 0 as 33 points. So I'll get 33 plus 31 plus again for 28 another 2 points, 30, like that. Sorry, here 32 points will be there. 32 plus 31 plus 30 and so on up till here 1 point. So here also I have to apply the sum of natural numbers from 1 to 33. So that is 33 plus 30 into 34 by 2. So 33 into 17. So it's very easy. So 21 and 51, 51 plus 51, 561 would be the points if I include the lines also, the integer points on these lines, then that would be the answer. So here we have to know how many integer points are there interior to this triangle. So that's an important problem. I hope you understood this one. Yes. Now let's move to mensuration. Mensuration is such topic where different types of questions can be asked. Like a cube is there, a metal cube is there. It is melted and has been made into different types of cones. I mean different cones, and the heights will be different. So here the problems would be easy to solve, and you have to be very good with your cubes, because in mensuration we deal with areas and volumes. So areas are nothing but within, they will be in squares, and volumes will be in cubes. So you have to be very good with cubes. You have to know what cube is there in your problem. For example, I didn't took any problems here because mostly IPMAT problems are not that good with when they don't give good questions in mensuration. So I wanted to discuss the problems. I want to derive the formulas for different shapes here. So we will deal with that. But let's see what type of questions can be asked from mensuration. So mensuration will ask you surface areas. Okay, surface areas of a shape when it has been intersected or cross-sected. For example, if a log has been cross-sected in this way, lateral cross-section, then what would be the new surface area increase? How much surface area has been increased? So when you cut a log laterally, that means parallel to its axis, that means you will form two semi-logs like this. Okay, so here the surface area would be always increased when you cut any surface. When you cut any solid, the surface area would be always increased. So here two new surfaces have been formed. What are they? This rectangle, this shaded part of this log, this part of the log, and opposite side of that part also were newly created. So 2 into area of the rectangles. Here the area of the rectangle will be found only through diameter into length. Diameter of this circle into that is diameter of the cylinder into height of the cylinder. That would be the area of each rectangle, and it has been 2 when you cut laterally. So 2 into surface, 2 into the area of two rectangles will be the new increase in the surface area. Like this, we have to find many problems in this way. So I want to discuss in this formula manner. So let's say this as a square. Sorry, I couldn't find any other diagram. So what is this length? It would be always equal S, and this would be S. So what is its area? It will be S square, and obviously the perimeter, it will be 4S. And apart from all these things, let's find the diagonal length. So diagonal length is nothing but, so I'm not drawing on his face, so imagine that it is a diagonal, so it's a right angle triangle. Now right angle triangle with diagonal will have S square plus S square, so that is equal to root 2S. Okay, so that will be the diagonal of the length of diagonal of a square. So in the similar way, can you find for a rectangle whose length and breadth are given to you? Yes, it will be root over L square plus B square. So that is about rectangle and square. So the properties of square and rectangle will be always known to you, because they are very easy. They are primarily basic things that we will learn in mensuration. What is that? A square will have two isosceles right angle triangles. It will form two isosceles right angle triangles. Here one right angle triangle is there, and here one isosceles right angle triangle is there. And again, if you cut it into diagonally, it will be always forming four new isosceles triangles again. So you can cut in a diagonal midpoint way, or in a diagonal way also. You can form four equal parts, whether it is triangles or squares. If you cut through midpoints, you will form squares, four equal squares. If you cut through diagonals, you will form four triangles, isosceles triangles. So that's about this shape, square. Then what about this? This is a circle. So circle's area, you always know that as pi r square with the radius r, and the perimeter would be 2 pi r. Fine. But what if this biscuit is halved? That means half of a circle, semicircle. Thus a perimeter would be half of 2 pi r, that is pi r, plus this r and r. So it would be r of pi plus 2. So that would be perimeter of a semicircle. Okay, I hope you all know these things. And obviously we have discussed about triangle, area of triangle, height of triangle, how to find it. We already discussed this in the previous problems. Now coming to the 3D shape. Whenever you come to 3D shape, you have to consider that you have to consider volume also. So what is the volume of this cube? So of length S, the volume will be S cube. So cubing of a single length. Okay, so that's why you have to be very good with cubes. So what is the cube of 1728? You can comment the answer. Cube root of 1728 and 1331 also. These type of problems, these two problems, these two numbers are more repeated in 3D mensuration, because 1728 is cube of 12. But if you divide it into two parts, like 1000 plus 728, this is cube of 10, and this is not any cube but 1 less than 9 cube. So it's 729 minus 1. So a problem can be designed here. A good mensuration problem can be designed from this, like saying this can be an error. Actually 1729, he can create a problem like this. A metal cube or a metal sphere, when it whose volume is like not a perfect cube, it has been melted and made it into a two different cubes of different sizes, but 1% error or something. What is 1 by 1728? It went as an error. It would be 1 by 12 cube, right? So some percentage can be given here. 1 by 12 is 1 by 8.33. 8.33 cube is 5.12% of error is there. That is nothing but this one. So if that error is removed, 1728 would be perfect cube, and 1728 can be again divided as two perfect cubes, that is 1000 and 7. Sorry. That 1% error can be added. So okay, fine. A design of question can be in any way. Okay. So 728 1729 is again 1728 is a perfect cube, and 729 is a perfect cube, 1000 is a perfect cube. So remember these numbers. Okay, so be good with cubes. Yeah, coming to the volume of a cylinder, it would be pi r square into height h. So pi r square h would be the volume of this cylinder. Okay, now again, what is the surface area? Surface area of this cylinder. Surface area of cylinder is nothing but area of this circle along with the total surface area of this curved part. When you cut open this curved part, it will be looking like a rectangle. So if this is 2 pi r and this is height h, the area would be 2 pi r h, this area. But along with two circles, we have to see it. So 2 pi r h plus pi r square plus pi r square, it would be 2 pi r square. So 2 pi r taking common, h plus r would be your total surface area of a cylinder. In the same way, when you go and find with a cone, so remember cone is 1/3 part, cone's volume is 1/3 part of the volume of cylinder, so it would be 1/3 pi r square h. Okay, and surface area, the latter surface area or curved surface area of a cone, if this is of height h and this is of radius r, so what would be slant height? It would be pi rl. Okay, so pi rl taken as slant height, this as height h, you can find the total surface area as pi rl, sorry, this is pi rl and height h. Okay, you can comment this surface area as well, total surface area of cone. Okay, I couldn't write it here. So yes, total surface area of cone. Please comment in the comment section. So this is all about a mensuration. So please be good with your elimination techniques in mensuration, because every time elimination do have cubes and areas. Whenever you have to deal with areas, you have to deal with squares. So if you are good with these things, mostly mensuration will be easily solvable, because it's all about the number game in this mensuration. So thank you people, thank you for this motivation that you are giving in comment section. Thank you very much.